Okay, what's that been, about a minute or so? Not even.
Yeah.
Yeah. You're out at the track and you've damaged a fiberglass body kit or something.
This is a perfect application for that. If you've got a small, medium, large patch in your kit, pull out the applicable size patch and then you just sort of whack it on, let the sun do the work, and then you're away again.
Traditionally, when people think about prepregs, we're thinking about autoclaves or curing ovens at the very least. You've got a very different system working here. Fiberglass, but it can be carbon fiber by the looks, and UV cure is the main thing. Can you just talk us through what's going on here?
Yeah, so this is just another way of looking at it. It's just another variant away from your traditional low temperature or high temperature prepregs. You take the prepreg out of the bag, you cut it into the shapes that you want, and you can put that on a molding situation, or sometimes we're doing a repair with it, or it's actually good for industrial applications as well. It's quite versatile, and all you need is to cure as a UV light. Yeah, as I say, cut into the shapes, put onto the mold, rolled out traditionally, just like you would any other composite layup, and then put the UV light on for a couple of minutes, and then voila, it's hard. You can literally take it off the mold. So yeah.
Cool. We'll have a look at that in just a minute. Just want to back up a little bit, I guess, to talk about what a prepreg is, because in case anyone's not familiar with that, could you just explain what prepreg means?
Yeah, prepreg is just anything that's pre-impregnated with the resin. Now, with the resin, that can be it can be an epoxy-based system, a vinyl ester, or a polyester-based system. So in any system, basically. With this system, we've got UV initiators that are inside the resin. So all that you need as an activation for that is UV. So we don't even actually need the UV light. You can actually put the prepreg onto the mold and then just sort of whack it outside for 5 minutes, and then you come back and it's hard. I mean, the beauty of that, it's got a really long out time. So you could take 2 to 3 hours to lay up the part, and then it's only when you add UV to it that it makes it go off. So, but to go back to your initial question, what is a prepreg? It's just anything that's pre-impregnated with the resin.
Yeah. And typically, obviously, like we're talking about the cure initiation there, heat and pressure from, autoclave would be the traditional ones. For a wet layup or an infusion-based system, it's going to be adding a catalyst or a hardener or something like that. But here, again, it's just UV light. So if it's not exposed to UV light, then it's not going to cure.
That's right. Yeah. It'll stay in suspense. I suppose a good point to note with the low temperature prepreg, which is available. Oh, it's a lot easier to do than your high temperature prepregs, the ones that sort of need the autoclave. But you can actually, and we have done it in here from time to time, is you put the low temperature prepreg on, and then you just construct a housing, which could be a table with some blankets and some heat in it, and just as long as you reach what the temperature says on the specification sheet.
So the resin flows and
Exactly. And you can actually do it on a budget if need be, yeah.
Let's jump into this a little bit more on the materials that you're using here. Obviously, we've got a bunch of glass behind us that looks like a double bias. And how is that then impregnated with the resin? And does it need to be glass, or any reinforcement's going to be fine?
Yeah, so it can be a combination of lots of different weaves, lots of different directions. So if we wanted to put a unidirectional in, couple that up with a biaxial, couple that up, we can even put some carbon in here if we wanted to. We're pretty flexible with what we can pre-impregnate. Now basically, to make up the prepregs, we use a bath. So the fibre comes in via a series of rollers, and then it essentially goes through a bath and it comes out the end with the right amount of resin to glass ratio.
Yeah. I think that's the key point here, right, is it's like a near perfect resin to fibre ratio compared to, like a wet layup. You typically have a lot more resin for the fibre. So the mechanical properties per unit weight are generally not as good, where prepreg it's a lot better. And then the manufacturing process has some different kind of advantages to it, I guess, in terms of the practicalities.
Yeah, that's exactly right. Because when resin equals brittleness, if that makes sense. So the more fibre you can get into the laminate, the better. And some chemical resistant applications, you actually want more resin to fibre ratio, but that's really the only industry that requires more resin to glass, if that makes sense.
Yeah, chemical resistance. Things like fuel tanks and such, maybe?
100%. And in those situations, you actually want a resin-rich laminate because you're not worried about brittleness, you're worried about chemical resistance.
But generally for mechanical properties, if we can get that resin content lower while providing the structure still, that's kind of ideal.
Yes.
Yeah. I just want to talk about some of these other materials we've got here. So what is the purpose of these films here as they're kind of applied to the prepreg?
Obviously with the UV, we need to keep it away. So if we were to expose the prepregs like these lights that we've got in here, they've got no UV, for instance. If we were to get any hint from a window or an external window coming in through, it's going to make it go off prematurely.
Yeah.
So what we want is we want to protect it. Hence why these films here, the top black one, that's basically a black backer, which we put on the back of the prepreg, and then we've got the bottom one, the gold one. That's 100% UV blocker.
Okay.
The middle one, so basically once the prepreg is in place and we're actually ready to roll it, more often than not we'll take the UV blocker off and then roll it with the clear film on, and then what we do is when we take that off, we'll cure it after that. So each one of these sort of has a different function, if you like, and it depends on where you are doing it. If you are out in the sun or there's any UV coming through, then you'll want to keep the 100% UV film on while you're doing all your processing, and then that just sort of gets taken off.
The first thing I think of there is if you're building up layers or a laminate. Is that still possible with this? Can you put down a single layer, take these films off, and then build up the next layer? And then when it comes to actually curing it with the UV light, is that still going to all cure?
Yeah, 100%.
Okay.
The laminate that we're going to have a wee play with in a minute, that's basically 4 layers of this, so it's about 4 millimetre thick in one hit.
Okay.
But it doesn't have to be. It could be a mil, and then you could sort of stack it up that way. If you want to consolidate each layer, layer by layer, I think we can get away with 8 millimetre worth of thickness before we sort of have to cure it and then put additional layers on. Because if it's any thicker than that, it just generates too much heat when it exotherms. Cool. Yeah.
Right, well, let's get into the actual practical kind of process so we can get a look at it and then just talk about some use cases afterwards. So, yeah, we've got some over here. If you could run us through the process.
Okay, so basically it traditionally comes in a black bag, and this particular prepreg is a certain size. So we've got 310 by 750 by 4 millimeters. But again, it doesn't have to be. It just happens to be that this is the size of the prepreg that we've got at the moment. And
as you mentioned, this is glass you've got here, but it could be carbon, it could be Kevlar. Or really any other reinforcement, flax or something even.
Yes, that's correct. It just depends what application it is and what material you want to be using. So I'll just sort of cut this up into. I've sort of marked a line on it, sort of where I want it, and then we've just sort of got a bit of a preform here that we're going to use to sort of drape that prepreg over. So normally it wouldn't actually be this thick, but normally you would have you would do it a little bit thinner than 4 mil, but it just for this application we are sort of using 4 mil, so hence it's reasonably hard to cut. And then so we've got our preform here, and so what we're going to do with that is we're just going to remove the black backer from the underside, and as I say, all of these are put on just to stop the UV from coming through and prematurely setting it off before you can actually roll it out. So what we'll do here, it just takes just peel that off, and as you can see, you've got the resinous prepreg in there. Yeah, what we can do with that, I mean, we're in a room that it's got no external windows, so we don't have any. We don't really have to worry about the UV in this room, but I will keep the film on there, just sort of to show you what it would normally look like. With this, you've still got you sort of don't want to get any of the resin it's sort of coming through on your hands. We'll just take this film, the top film off there. And we're just going to consolidate that laminate and just take as much of the air out as we can. With the rolling, we're rolling 4 layers at a time, and it's quite heavy. But normally we wouldn't sort of do something this thick, if you like. So we're just going to consolidate those layers there, and by leaving this film on, it actually gives you a nice surface. So once it's cured, we can pull that clear film off, and it leaves you with a nice glossy finished surface. Yeah. To be fair, you can use peel ply as this. If you're going to be doing secondary bonding, you would just put a peel ply on that. What we'll do, just for the sort of the purposes of this, we'll give that a bit of a cure now. And then we'll pop it off the mould. With the UV, when we're curing it, we just have to put some glasses on, just because the UV itself is quite powerful, and it's sort of best to keep it away from the eyes. So grab the UV light there, and as I say, it's a reasonably powerful light, but in saying that, you can get a UV light that is the right light that you need at JCar for, I think it was $9.50 or something like that. Or alternatively is just...
take it outside.
You take it outside. So you can just sort of hear it, just sort of starting to set there now. So it's pretty much done.
Yeah, what's that been? About a minute or so? Not even.
Yeah.
Yeah.
So we'll just do it for a little bit longer. Sometimes the UV just takes just a little bit to penetrate through the full sort of 4 millimeter.
Yeah.
So normally what we do is we just sort of whip that off, and then you like, if you feel the surface, it gives it a nice...
it's warm, but it's smooth.
A nice smooth sort of finish. And then we'll actually just see if we can pop that off there. And then, it's...
Yeah, so a minute curing time compared to, I guess, a normal pre-preg would be 12 hours or something like that.
Yeah.
At least, yeah. Oh my God, yeah. So a couple of questions come to mind. Mechanical properties of something that cures that quick, is that going to be kind of comparable, you'd say, to a more traditional approach? Is it going to take a hit in the mechanical properties?
Essentially, no.
Okay.
Yeah. So we're using a vinyl ester resin system, which has reasonable sort of properties, sort of a step up from your polyester, if you like. And then if you want higher properties after that, you can go to an epoxy UV cure system, and essentially works the same way. So you're not losing any properties. Yeah.
Okay, cool. And if we talk about, and obviously the properties will come back a lot to the reinforcement that's used and the number of layers and so on as well. If we talk about the use cases of it, you talked at the start a little bit about industrial stuff, so I guess, and repairs as well, so out on site making repairs. But we would be able to kind of template this and lay this into molds just like we'd do any other kind of composite construction, and then it's just a matter of exposing it to UV rather than in an autoclave.
Yeah, that's exactly right. As I say, we're using a 4mm laminate there, so it's reasonably thick, and this particular laminate's designed for an industrial application, whereas if you were doing, let's say, 4 layers of 200 gram carbon, which would be roughly 1 millimetre, easy to cut with the scissors, easy to cut into shapes if you've got templates or what have you, and then easier to roll out as well.
I just kind of think that maybe you're out at the track and you've damaged a fiberglass body kit or something, you could do a quick repair with that maybe rather than some cable ties.
This is a perfect application for that. Yeah, definitely, because you just need to pull it out of the bag, and potentially if you've got a small, medium, large patch in your kit, pull out the applicable size patch, and then you just sort of whack it on, let the sun do the work, and then you're away again. So.
Yeah, right.
It's not messy, although when you've just got to be careful that you don't expose your hands to the actual resin itself. But you don't have to get to pour resin out. You don't have to measure the catalyst. You don't have to cut the fibre. You don't have to. It's an all-in-one.
Yeah, like practical realities of it are a lot more kind of simple, even though maybe the engineering's not so much in the first place. Yeah, awesome. Well, I think that gives us some insight into a really potentially accessible alternative that, yes, like could have some really good practical use cases. So thanks for showing us that. If anyone wants to learn a bit more about this or see what you're doing, where are they best to do so? So
we've got a website at f-i.co.nz, or just reach out to us. All our details and phone numbers are on the website. Yeah.
Perfect. Cool. Thanks for your time.
Yeah, no problem.